All right, Noelle, this is our chapter 12 review. This is our last video before you take the test, and that'll be the last test in geometry. But the very first section was just a matter of identifying shapes. A prism, you know, looks, these are both prisms, okay? This is what we, and they're named by the shape of the bottom. So this is what we call a pentagonal prism. This is a triangular prism. Okay, pyramids. Pyramids all come to a point, but they too are named by their base. So this would be what I would call a square pyramid. You can have octagonal pyramids. You can have hexagonal pyramids. A cone comes to a point. A pyramid always comes to a point, but a cone comes to a point and has a circle on the bottom, you know, like an ice cream cone or a roadwork cone. Cylinder, it's like a can. It has two bases to it. And a sphere, of course, is like a ball, like a basketball, okay? That's going to be your sphere. So make sure you know those, but also make sure you know how to name the parts of those. So like the base is what it's sitting on. If it's a prism, it's going to be, the base could actually, if it's a rectangular prism, it can be any of the sides. But if it's an octagonal prism, it would have to be the octagon, or going to be the base. And a prism would have two bases versus a pyramid is only going to have one. So the base here would be A, C, D, and E. Then your faces would be the four triangles that make up the sides. So make sure you get all four of them. Triangle ABC, triangle BCD, triangle EBD, triangle BAE. Edges are all your straight lines. So BC, AB, AC, CD, DE, AF, BE, BD, and BC. I might have repeated some of those. Your vertices are all your points where your edges come together. B, C, D, E, and A. Okay, so make sure you can do all that. That basically is your section 12.1. Section 12.2, we began to talk about surface area. And the very first time we talked about surface area, we talked about doing it the long way, where you find the shape of each side that you have. Like for instance, let's say I have something like this. I'm going to find the area of each of your triangles, and then I'm going to find the area of each of my rectangles. If I could draw that out, and there's no guarantees on that, I'm going to try. By the way, we very well might end up having two videos to go here because I'm not sure whether I can get everything done in one video. That looks terrible, but you get the concept. Okay, you have a triangular prism, and this is 6 and this is 9, and that's about all you know. So you've got, and I think what we'll do is we'll stop here. Golly, I wish I could draw that better. Okay, let's try it a different way. Hold on. You know, drawing is not my forte. Okay, somewhat a triangular prism. We've got 6, we've got 9, okay? So I know I have the two triangles, the front and the back. I also have the bottom. I have the front, which is this part that you see right here. And I also have the back. And so the old-fashioned way to do it is to find the surface area of each one of those. Well, I don't have all the parts of my triangle. So I've got the 9, and then I've got this part right here is 15. So I would have to, well actually, I think I've got the 6 and the 9. So yeah, I do know that it's 15. Okay. So then I've got, I got to find this other part. I've got to find this side right here because that's the height of my triangle. So I'm going to use Pythagorean theorem. 15 squared minus 9 squared is equal to b squared, or the height squared. B is going to equal 12 after you use Pythagorean theorem. So triangle, I have 9 times 12 times 1/2 times 2, because there's 2 of them. So I have 2 times 1/2 times 9 times 12. Well, those two are equal to 1. So the triangle gives me a surface area together of 108 units. Okay, so that's one thing I'm going to use. The bottom here is 6 times 9, so that's 54. This top is 6 times 15, which is going to give me 90. And then I've got the back, which is going to be this times 6, which is going to be 72. Okay, hopefully the drawings on the test are much better than my drawings. Okay, then I would add up all the individual parts, and I would get 324 units squared. And that's the total surface area of this. Now we learned how to do it later, a much easier way, where we found the area of the lateral area and then added in the bases. And it works here, but we didn't know how to do it yet in this particular section, but obviously you can use it now anytime it's applicable. Now you can lay it out, but I noticed on your homework you did not, so we're not going to lay it out with a mat drawing where you actually unfold it and lay it flat. Section 12.3 was on surface area of a prism, which was just like that. I should have left that up there, but basically the surface area of the prism is a shortcut to what we just did. So let's say we have a hexagonal pyramid. So something like that, okay? I know that this is 4 centimeters, and I know that this is 10 centimeters. Okay, we talked about the lateral area. Let's see, do I have something similar to it? Okay, this is a pentagonal, but the lateral area is the area of these all the way around it without the 2 bases, okay? Now, the lateral area I found out is equal to the perimeter times the height. So I would find the perimeter of the base. So this is 4 times 6, or 24. The height here is 10. So I have a lateral area of 240 centimeters squared. Now sometimes they're just asking you for the lateral area, but sometimes they ask you for the total area. So the total area is going to be your lateral area plus the area of the 2 bases. So I have to turn around, I have to find the area of this hexagon, which is not what you really like to do, because then I have to bring in the perimeter times the apothem. Okay, I'm going to bring out one of those triangles. This is from the last chapter. If I have 6 central angles, this is going to be 60, because 360 divided by 6. When I cut it in half, I get a 30, and that's going to be a 2 and a 2. I want to find the apothem, because remember, the base is going to equal 1/2 the perimeter times the apothem. So I'm going to do the tangent of 30 degrees is equal to opposite over adjacent, which will be the apothem. So it's going to end up being A is equal to 2 divided by the tangent of 30, and you're going to find that the apothem there is 3.5. Oops, was I right? 3.4. So I'm going to plug in everything. I know the lateral area, 240. The 2 times the 1/2 just totally goes away. So then I take the perimeter, which again is 24, times the apothem, which is 3.5. Put that in parentheses, okay? Otherwise your calculator won't do it right. And that's going to give me 324 centimeters squared. And that's going to be my total surface area. All right, then we talked about, and things got a little bit easier at this point, we talked about cylinders. Again, you have lateral area and you have total surface area. The lateral area of a cylinder is 1/2 the perimeter times, oh wait a minute, no, wrong thing. 2 times pi times r times h, because remember it's the circumference of one of the bases times the height. Okay, now that's lateral area, that's not total surface area. Total surface area would be 2 times pi times r times h plus the 2 bases, which have pi r squared as your formula. So let's say I have 19 inches here, and this is 17 inches. Okay, if I just want to find the lateral area, I've got 2 times r, which is the same as the diameter, so I've got 19 times pi times 17. The lateral area is 1014.7 inches squared. Total area is going to be that plus 2 times the area there. Now, if that's 19, then I'm talking about 9.5 as a radius. So pi times 9.5 squared. Don't forget to put parentheses around that whole last part, and that will give me an answer of 1,581.8 inches squared. All right, that was section 12.4. Section 12.5 was the area of a pyramid. Now on a pyramid, you've got 2 things. You've got the altitude, and then you also have the apothem. Your altitude is dropped straight from the center down, and we'll just call that the height. And then that would be the apothem. Or we would also call that, and we'll do it here, the slant height. And then let's call this the altitude, so that we can switch and use an A. Choose an A there, and that's an L, a cursive L is what you see there. Okay, the lateral area, or the distance around the side of this, is going to be 1/2 the perimeter times the slant height. The total area will be the lateral area plus the area of the base, depending on what the base dimensions are. Let's say this has an altitude of 11, and it has a slant height of 12, okay? Now what I don't know is I don't know what each side of those are. So what I'm going to do is I'm going to draw a triangle right there. So let me pull that triangle out. This is your altitude, which is 11. Your hypotenuse here is your slant height. That right there is going to be halfway across my square, if you will. So when I work that all out, I find that each, let's see, I think it's 4.8, but let me see for sure. Okay, 12 squared minus 11 squared. I'm going to take the square root of that. And it's going to give me 4.8, but I'm going to double it because I want the whole side. So that's going to be 9.6. Okay. 9.6 times 4 is going to give me the perimeter of 38.4. And then I also need to find the area of the base, which is going to be 9.6 times 2. Oh no, 9.6 times 9.6, sorry. It's going to be 92.16. All right, now I should have everything that I need. Coming over here, if I just want to find the lateral area, it's 1/2 the perimeter, which is 38.4, times the slant height, which the slant height is 12. So the lateral area here is 230.4. But then to find the total area, it's going to be the lateral area plus the area of the base. Now I only have one base here, so it's just plus 92.16. And that's going to give me a total surface area of 322.56. I think they were inches, but inches squared are units squared. Okay. All right, let me check on this video.